Module 17. In this section, first I will start with NAT oversubscription and then dynamic IP and port translation for ICMP packet traffic or ICMP packets, right? Because dynamic IP and port translation means translating both source IP address and source port address. So for TCP and UDP based applications, no problem whatsoever, right? Because TCP or UDP based applications means like IP header and next to it like TCP UDP and then application data. So layer 3 address like IP address, layer 4 address, that is port address, both are there, both are translated with this dynamic IP and port in Palo Alto, also known as DIB. In Cisco, we call it like port address translation or overloading. In Checkpoint, like hide NAT, many to one translation. But point to understand here is how like ICMP packets are translated by any firewall, because ICMP messages are encapsulated in IP packets, correct? No like TCP or no UDP ports. So how does a firewall translate ICMP packets? That's really very important to understand. You might have not noticed, like in firewalls, I mean, right? Because we mainly care about like TCP and UDP based application, and we think that dynamic IP and port is dedicated to TCP and UDP related traffic only, and not to other IP protocols. Up to certain extent, yes, correct, because there has to be a port address, right, are equivalent to port address, some other value, some other information for this dynamic IP and port. And if you remember, in ESP packets, I mean like in IP6 site-to-site VPN, IP6 site-to-site VPN, packet is further encapsulated inside like ESP. Additional IP header is added to the original packet. Is original packet uh, TCP based application means like IP, TCP, and then again here data, and then ESP encapsulating security payload trailer and ESP auth or authentication, right? So original packet is encrypted, encapsulated. So if there is a NAT device in front of VPN gateway or a firewall device, okay, so again a big challenge here, because NAT device cannot perform IP and port address translation, because ESP is again what, like protocol number 50, no TCP or UDP, right? IP protocol basically. So again the same problem, because in order to translate source IP and source port address, there has to be source port address, and the TCP or UDP header is encrypted, okay, cannot be decrypted by the NAT device that is in front of a VPN gateway. So the workaround here is what? Enabling a very good feature in VPN, that is NAT traversal. It means this ESP packet is further encapsulated inside UDP port 4500, so that the device in front of VPN gateway can easily do the IP and port translation. So do we have similar option for the ICMP packets? No, not exactly. And if you remember, so you never do anything for like this ICMP translation, right? So whether it's a Checkpoint firewall, Palo Alto firewall, Cisco ASA, or any firewall device, if like the device has NAT policy or NAT rule for this, like a dynamic IP and port or maybe PAT translation or overloading, so really we don't do anything for this ICMP traffic. Like once like NAT rule or policy is created, So not only TCP and UDP packets are translated and routed successfully over the internet, ICMP packets are also translated, right? You must have seen, like, if you want to ping any destination IP over the internet, so yes, you can do that. Even if your computer IP, your machine IP is any private IP address, non-routable over the internet, still you can ping public IP address. Okay, and you understand pinging means what? ICMP packet. It means firewalls easily handle ICMP packets. But how? I mean, like, if there is no port address, say, so what would happen in fact? So I will talk about that, right? But first thing first. So first, I'm going to start with NAT over subscription. Over subscription, and in general, over subscription means like over subscription. So if I take example of a Nexus switch or any other switch, so here if you have a switch and a line card input output module, in fact, and a line card has total 32 ports, right, and 1 gig port, and overall throughput of the line card uh, is, let's say, 80 gigs only. 80 gigs. So you understand, if there are total 32 ports, and each port is of 1 gig. So ideally this would have been total 320 gigs throughput, right? 320 gigs, because there are total 32 ports and each port, like, data transfer rate is 1 gig. But if the line card has overall throughput 80 gigs, not 320, so technically what we call it like there is oversubscription of 1:4. It means a software on a chip or hardware IC, and is like capacity throughput is of like 1 gig. So 4 different ports are handled with it, right? It means if you use all 4 ports, so each port cannot operate at 1 gig bandwidth. So technically we use the term oversubscription here. That is oversubscription of 1:4. So if really we want to like have dedicated 1 gig data transfer rate, so cabling should be done in very smart way. If like in a port group there are 4 ports, so use 1 port and leave 3 ports unused. So this way, like you can have 1 gig data transfer rate. But what if a line card has like 32 ports and 1 port of 1 gig, and total throughput is 320 gigs? Okay, so now technically we use the term line rate, that each port is operating at line rate 1 gig per second only. There is no oversubscription. So in networking devices, it's very common term, oversubscription, right? Oversubscription of 1:2 or 1:4, or another term, line rate. Okay, it's networking term. But what is NAT oversubscription? NAT oversubscription. So I'm going to explain that, right? So first I'm going to start with NAT oversubscription, and then I will explain how like ICMP traffic is like translated with this dynamic IP and port. Okay, and the same concept, the same rule, like this dynamic IP and port translation for ICMP is same for all firewalls. So it's not like very specific to Palo Alto only. But first thing first, and first, like, let's understand NAT over subscription. So I'm starting with dynamic IP and port translation first, and then I'll talk about NAT oversubscription. So on the LAN segment, there are two host devices, one with the IP 10.0.0.2, another machine with the IP 10.0.0.3. So if 10.0.0.3, this computer wants to access any destination over the internet, so sends like request packet hits the firewall, and source IP address here is 10.0.0.3, and source port address any random port number, right? Authenticated port number, and generally like the higher port number, like beyond like 1024, and destination address here is 888 and let's say 23. So what happens, like after the NAT is a before NAT. So after NAT, source IP address source IP address is translated with 124.123.100.82. 124.123.100.82. Source IP address is translated, right, with the interface IP address. Even we can use any other IP address that is not basically assigned to the firewall interface. That's okay. We can use, right, as long as the IP is routable. Packet coming from the internet side is successfully routed or directed to the firewall. So yes, we can use that IP in the NAT policy. And even like it's not recommended that you should use a firewall interface IP in your NAT. You should always avoid using interface IP. But for this demonstration purpose, let's understand like the interface IP address is used here in the NAT. So source IP 124.123.100.82, and source port address is also translated, right? And that's what dynamic IP and port means. Source port address is also translated to any random port number. For example, 10,001. What about the destination? Destination address and port address, they both remain same, unchanged, right? Port number and destination IP address. And now the reply packet comes back to the firewall. What firewall does now? Firewall does translation again, and this time source and destination. So source and destination, they both will be flipped. Source would be now 888, port number 23, or whatever the port number is, maybe 53 like DNS. If I take the DNS, then 53, but that's not important for us. And destination IP address translated back to 10.0.0.3 and to the original port number, right? And how like it is done? So basically firewall maintains NAT table entry, right, locally there to do the mapping. And let us assume another request packet comes from another host 10.0.0.2, right? Sourcing 10.0.0.2, a port address here 15 maybe 009 or something, destination 12.0.1.28, port number 23. Again here IP and source IP and source port address both are translated. So IP address 123.100.82, and this time if the port number 10,001 is already in use, not released yet, only one connection. So in this translation, a different port number will be used. Okay, different port number to make this connection unique. So generally what happens, firewall uses different port address, and then destination remains same, and again reply packet comes back, and you understand the whole story. So the whole concept you understand, right? In dynamic IP and port translation, source IP address and source port address both are translated. Source IP address and source port address both are translated. And as we know, like total number of ports available is equal to 1,265,535 and like 1024 almost like because there are a lot of reserve ports and well-known ports, right? A lot of reservations are there. You must be knowing, right? So for NAT translation, 64,512 ports are available and used in Palo Alto Firewall. 64,512 ports total means total 64,512 concurrent sessions. How many sessions? Number of sessions is equal to 64,512, right? Checkpoint firewall uses like port number from 10,000 to 60,000. 50,000 concurrent connections there in checkpoint firewall because source port numbers are used from 10,000 to 60,000. In Palo Alto firewall, it's 64,512. So a lot of ports are excluded, right? Well-known ports, reserve port, and some other ports. So what if number of concurrent sessions exceed 64,512? What would happen then? Of course, no translation, no translation at all. And can we understand like this way, like 64,512 ports means total 64,512 computers or host devices on LAN segment? No, I'm not saying that. 64,512 concurrent sessions. So even a single computer, right, can have maybe 50 active sessions, 100 active sessions, depends like on the number of destinations and even like the requests and response messages, right? Because in previous version of HTTP, like HTTP 0.9, in fact, there was 1:1 relationship between TCP and HTTP connections. So in order to load a web page, maybe there can be more than like 10, 20, 30, 40 or 60 TCP connections, and on top of that maybe 60 or 70 HTTP connections. However, nowadays there is no 1:1 relationship. I mean, like if there are like total 100 HTTP messages exchanged back and forth, like HTTP request and reply messages. So definitely nowadays there won't be 100 TCP connections, right? Because there is no 1:1 relationship nowadays. We are using HTTP version 1.1. So keep alive is supported in HTTP version 1.1, and keep alive means TCP connections are reused. I mean, like on top of a single TCP connections, multiple HTTP requests and response packets are exchanged. Okay, but still, if there are 100, for example, HTTP connections, so there can be 20 or 30 TCP connections. Not to be surprised with. Means 64,500 concurrent connections. How many clients will be supported? So again, like depends, like because we can only talk in terms of number of concurrent sessions, not about number of concurrent like number of clients. No. So is there any way to increase number of concurrent NAT sessions in Palo Alto Firewall? Is there any way? Can we reuse IP address and port? Can we go beyond the default limit? Default limit, I mean like approximately 64,000. The actual number is 64,512. And answer is yes. And that's what NAT oversubscription means. So basically NAT oversubscription allows you to use each translated IP address and port pair multiple times, right? So IP and port pair, IP address of course same, and the port number, for example, 10,001. So this IP and port pair can be used multiple times When if we enable NAT oversubscription. If NAT oversubscription is like 1:1, so technically there is no oversubscription. 64,500 concurrent sessions and would remain 64,512 only. 1:1. So basically it's not oversubscription, not oversubscribed, right? But if NAT oversubscription is something like 2, like 1:2, or maybe 4 or 8, means what? IP and port, like this dynamic IP and port now, NAT basically will allow IP address and port pair 4 times or 2 times or 8 times in current session. And as a result, let me take this example. If NAT oversubscription is just 2 times, so what would happen? Now this Palo Alto Firewall will support maximum 64,512 multiplied by 2, and whatever like the number comes, concurrent sessions, right? Approximately 129K approximately. So number of concurrent connections or sessions have increased now. What if the like the oversubscription is 4 times? It means IP and port pair both, right, will be used 4 times. Means 64,512 multiplied by 4. And the design is based on the assumption that hosts are connecting to different destinations, right? And therefore a session can be uniquely identified and collisions are unlikely. Okay, so NAT oversubscription means what? Increasing number of concurrent sessions, right? And there is a default oversubscription rate limit in Palo Alto Firewall, default, and default rate is something like, if I talk about a VM series firewall like VM 100, 200, 300, or even like PA 220 or 300 or 850. So default oversubscription rate is 2. In like PA 3220, even 3250, 3260, even 5020, oversubscription of 4, and higher end like the PA 5050, 5060, even 7050, oversubscription of 8, right? So default rate for VM series firewall is equal to what? 2. It means if I am using VM series firewall and if I check the like number of concurrent session, and for that we have one command here, and I'm going to show you that command. Show running and what? IP pool. So number of concurrent connections should be here like 64,512 multiplied by 2, somewhere around 129, right? And then 000 approximately. So because I'm using a VM series virtual firewall, that is why. So basically this oversubscription is what? Reusability of IP address and port. Understood? And assumption is what? Different destination. Different destination. Because connection, each connection must be unique. So if destination is different, so definitely a connection would be unique. And oversubscription of 1:4 means using IP and port pair 4 times, using same IP and port 4 times, right? And that is why total number of concurrent connection will be increased by 4 times, 64,512 multiplied by 4. So very quickly I'm going to show you the command here, and if I run the command show running IP pool, and see here 129024, right? And ratio is what? Ratio means oversubscription rate is 2, and only applicable to like IP, dynamic IP and port translation. So dynamic IP rules here, right? 129.024, and if I run another command, the uses. So the other command is here is show running global IP pool. So you can check like the range here, like use in the IP or dynamic IP, and then here also like there is another dynamic IP and port. You can check the size and total number, and just like dynamic IP and port 0.12% only. Okay. So if in case if you want to change the default oversubscription rate in Palo Alto Firewall, so just go to Palo Alto Firewall web UI page. So go to device tab and session. And look at the option here, like the default selection is NAT oversubscription rate, platform default, right? So platform default is something like for VM series firewall, default oversubscription rate is 2, right? So in case if we want to change NAT oversubscription rate, so click here like gear symbol, and NAT oversubscription rate can be 1x, 2x, and 1x means what? Basically, no NAT oversubscription. 1x means no NAT oversubscription. And if I select here 4, it means 64,512 multiplied by 4. So we have increased now number of concurrent sessions. And let me decrease the font size so that the space can be adjusted properly, and hit on the OK, commit. All right. So see here like the NAT oversubscription rate is 4x now. It means 6, 4, 512 multiplied by 4. So total number of concurrent connections should be now 258,048, right? So IP and port pair will be used 4 times. So oversubscription is like in simple one sentence, you can say that oversubscription in Palo Alto Firewall, I mean like the NAT oversubscription in Palo Alto Firewall means increasing number of concurrent sessions or reusability of IP address and port. Okay. And without oversubscription, NAT oversubscription feature, maximum number of concurrent connections is equal to 64,512. All right, so let me check commit completed or not. Yes, completed. And see here, show running IP pool. So this time 258048. The same figure 258048. So I hope you understand the concept of NAT oversubscription, right? A very common question in like particularly in the tag interviews, in fact, NAT oversubscription. So I hope you understand concept of NAT oversubscription. Now let me talk about another important like concept here, and that is ICMP packets. right? So as I said before, ICMP messages are encapsulated in IP packets, right? It means IP and then ICMP. ICMP is basically Internet Control Message Protocol, and if further I talk about this ICMP header and all that, so ICMP header means like 8 bytes, header itself and plus data. So if you remember, so in Cisco router, whenever we run the command like ping and then any IP address, so by default, 100 bytes, like the 100 bytes is the packet size, right? So a packet of 100 bytes is sent. But 100 bytes means what? 100 bytes means IP and ICMP, right? ICMP header, IP header is of minimum 20 bytes, ICMP header 8 bytes plus data. So data means 100 bytes minus 20 plus 8, 28, 72 bytes. So actual data payload here is 72 bytes. Okay. So 100 bytes means IP header of 20 bytes and then ICMP header 8 bytes plus variable data, right? So 100 bytes means actual data is 72 bytes. So let's talk about this header only because uh, understanding like this, the whole concept for that only you should be knowing ICMP header. So IP and ICMP. So ICMP 8 byte header means total, of course, 8 bytes. So it has like ICMP type, code, checksum, identifier, right? Identifier also here. So and some other fields also, right? Sequence number, another important sequence number. So type is something like of 1 byte, that is 8 bits. Code is again 1 byte or 8 bits. And type and code, I hope you understand, like ICMP has different type. For example, type 3 message means destination unreachable message. Destination unreachable, right? But in destination unreachable itself, like there can be like uh, uh, in fact host unreachable or network unreachable or destination host unreachable, protocol unreachable, port unreachable. So for that there are different codes. So type 3 code 0 means destination net unreachable. Type 3 code 1 means host destination host unreachable, and so on. In ping also, like type different type and code like messages are used like for echo request and echo reply. Okay. And you must have seen like when we run the debug command in like iOS based devices, maybe on like ASA firewall or Cisco router. So we get output similar to this, like type 8 code 0, type 3 code this, or ICMP redirect like type 5. So type and code is for that purpose only, right? Type and code is for that purpose. Checksum you understand, like for the error checking and all that. But there are two other parameters, identifier and sequence number in the ICMP header. Identifier and sequence number, right? So identifier is of 16 bits, and identifier basically matches the echo request with echo reply packet, right? And identifier and another attribute or parameter here is sequence number in ICMP header. So sequence number is again like 16 bits, and normally sequence number increments by 1 for each echo sent, for each echo message sent. So for that reason, for that purpose, like identifier and sequence number, they both are used in ICMP, right? So what Palo Alto does in like dynamic IP and port translation, basically Palo Alto Firewall takes like this identifier, ID, and sequence field, right, from the ICMP header and treats them the same as if they were ports. Okay, they were ports. So this uses the identification field as what? Identification field as source port reference, source port reference. Okay, and sequence field, this one, as destination port reference. And coincidence is identifier and sequence number, they both are of 2 bytes or 16 bits. And what about the TCP and UDP source and destination port address? Same 16 bits, right? Port address is also of 16 bits, and that is why there can be maximum 2 raised to the power 16, that is 65,536. So if we start from 0, however 0 is reserved, then maximum can go up to 65,535. So here in ICMP, identifier and sequence number, they both are of 16 bits. So ICMP, in ICMP header identifier is equal to source port and sequence number is destination port reference, right? Used like in the NAT translation mechanism. So this way ICMP is successfully translated, right? So even there is no as such source port address or destination port address, but still ICMP packets are translated by the NAT, right? Because here identifier and sequence number, they both are treated as the source and port address. And even we can check all this, like I mean like from the session ID and all that, you can find out the information. Let me show you. Let me go to one of the machine behind the firewall, and can we launch ping from here? So let me quickly show you. So I'm just pinging 888 through the firewall, right? And there is proper reply packet coming from 888. So there is like successful translation. Okay. So now I'm going to show you like this translation in fact from the CLI. Show session all filter destination. What is the destination? 888 and protocol number pro oops destination 888 protocol number 1 is for ICMP, right? Protocol number 1 for the ICMP. And yes, there is a active state here, and flag is network translation source NAT, source NAT, and the session ID here is 742, then 678 and so on. So let me be very specific, and session ID 742. So there are two flows, client to server and server to client. And protocol number here 1 and the source port, right? Even though ICMP means no port address, but source port and destination port. Okay, source and destination port. And what about the reply packet? That is source server to client flow flipped. Source port now 60 and destination port is 80. See here, right? So basically, source port and destination port is basically what? So as I mentioned, in fact, source port and destination port means identification and sequence number fields of ICMP packet. Okay, so sequence field and identification. So they both are treated same as if they were like ports, in fact. So identification means source port. Identification means source port. This one, source port 1 means like identification number, and sequence field is what? Destination port, and it's the response packet. Good. So I hope you understood how like ICMP packets are translated by this dynamic IPN port in Palo Alto and other firewall like PAT are overloading, right?